All right. Hello, this is Dr. Morgan. We want to get ready today to prepare for our semester final. And so I'm going to walk through the practice final with you to help you get ready. Remember, this practice final is exactly like the semester final, except that the numbers have been changed. So let's look at the first problems. It says, first, choose the graph that matches the function. Well, a couple things I notice here. I have a parabola. That's usually a quadratic with an x squared. Here's one of those absolute values, either this way or this way. So I'm looking for an absolute value. This is my exponential, and this is my linear. So let's match them up. First of all, when I come over here to number 1, first thing I notice is I have an x in the exponent. Well, the moment I see x in the exponent, I'm thinking exponential. And the exponential function is the one that is either always increasing or it's always decreasing. And so I'm going to look here and say, okay, number 1 has to be C. Okay. Next one, I'm noticing here in an exponent again, but it's not an x, it's a squared. And whenever I see an x squared in any fashion, I know that's my quadratic equation. And that's the one that gives me either a parabola that way or that way. If the parabola is happy, it's a positive coefficient, it's x that way, and negative that way. So that means number 2 is going to be A. Number 3, I simply have x by itself. When you have x with no exponent, it's just x to the 1 power. This is our linear equation. It means line. So our answer is over here. This is going to be D. And then finally, the last one, notice those brackets? Those are my absolute value brackets. And the absolute value means how far is the number from 0, which causes positive numbers and negative numbers on opposite sides to be the same. And that's what gives it either a graph that looks like that, or if it's a negative absolute value like it is here, it turns it upside down. So this is going to be B, and the answer there is C, A, D, and B. On the next problem, it's asking us which graph is not a function. You remember, to be a function means that for every x there's only one y. And when we have a graph, what we do is we come along and we draw a vertical line. And if the line ever crosses the graph in 2 places, it's not a function. So notice here, if I draw a line here, it crosses here and here. So because it crosses 2 places for the value of x, it has 2 values. This is not a function. So the answer would appear to be A. Let's check the others just to be sure. Notice wherever I draw the line, it only crosses 1 time. Again here, only 1 time. It never crosses twice. And here again, never crosses twice. So the one graph that's not a function is A. All right? All right, let's look at problem number 6. The graph shows the population of mice in a study modeled as a function of time. The study begins on day 2 and ends on day 200. Choose the statement that is false. The mouse population was at its greatest around day 160. Well, here's the greatest, the highest it is, and coming down here, it looks like that is about 100, 120, 140, 160, so that appears to be true. The mouse population was increasing between 100 and day 140. So at 100 it was here, and at 140 it was here, and notice it is going up, so that's true. There's 2 intervals where it's increasing. Well, we see 1 there, but notice it would also be increasing here, so that one's also true. So apparently our last one's going to be our answer. The least number of mice was about 142. Well, the least amount is about right here. Well, let's find 142. So 120, 140. And so notice here, 142 would be about there. That is the least amount there, but notice over here, I have 120. So the least amount, while it's the least coming down there and going back up, it eventually gets lower. So this is my false, so my answer is D.